Hey, welcome to this video. Here I'm going to be looking at some of the hardest questions in the C2 exam. So these are the questions that I've got for you today. You can use this video in a couple of ways. You can either play it straight through and make notes, or you can pause here, have a go at these questions and then mark your work using my answers. So each question is going to be worth 6 marks. If we're working at a mark per minute, which is what you should be doing in the exam, I'd expect this to take you about an hour. And these questions are deliberately hard. You have to be testing yourself, I have to be testing you to make sure that when you go into the exam you can feel happy, you can feel calm, you can feel confident, that you know what you're talking about, that you know how to get the top marks. We want nice, relaxed feelings as we go into the exam. Now, some of these questions may not look very hard, but I've marked a lot of exams, I've seen a lot of mark schemes, and the examiners are very, very particular in how you use your language. So some of the questions may look easy on the face of it, but unless you write the right words in your answer, you're not going to be getting these marks. So these questions, if they came up in the exam, would be broken down a lot more for you. There'd probably be several parts to it. There might be a picture, there might be some text describing it as well. But I've made them short and simple here so that they're deliberately testing for you. If you're not sure about the mark scheme for any of these questions, pop your answer in the comments below and I'll mark them for you and then I can give you personalised feedback. So this is our first question about diamond and graphite. Hopefully you know that both diamond and graphite are purely made of carbon, but their structure and their properties are very, very different. So I'm just going to quickly write down the answer and get back to you and explain it in a second. So this is my answer here. Whenever you get your long 6-mark question in the exam, you need to be smart. You need to be thinking about what the examiners are looking for in a mark scheme. So here I'm asking about 2 different things, diamond and graphite. For 6 marks, I would expect 3 marks for diamond and 3 marks for graphite. So I've divided my page in 2. I've done 1 paragraph about diamond, I've done 1 paragraph about graphite. When you mark yours, I want you to limit yourself to a maximum of 3 marks per point. An entire, A-level standard paragraph about diamond is not going to get you 4 marks if you don't say anything about graphite. So, diamond, all 4 of the electrons, let me write that in there, all 4 of the electrons in carbon are bonded to other carbons. They have very strong intermolecular bonds, which needs lots of energy to break them. So it has a high melting and boiling point and is a solid at room temperature. Each place that I'm giving a tick, you can give yourself a tick as well. And finally, diamond is very hard and strong. Now you can see I've written lots more about diamond there than is going to be allowed in 3 marks that I've given myself. So you can see there is a bit of leeway in the mark schemes. They're generally going to be more the mark scheme than you can actually get marks for, which is really, really good thing for you. So in graphite, you need to know that only 3 of the electrons are used in bonding. This leads to layers. They love this word in C2. And the layers can slide over each other, making graphite soft. The 4th electron is free to move in between the layers, and this means that graphite can conduct electricity. So to summarise the main points between main differences between diamond and graphite. Diamond is very hard. It's a very typical giant covalent structure. It's got a very high melting and boiling point. It's solid at room temperature, and apart from being very, very pretty, chemically isn't that interesting. Graphite, however, is very, very interesting. So it's made up of exactly the same things, but the way the electrons are involved in bonding means it's very soft and it can conduct electricity. So this is our next question here, and because I wanted to make each question worth 2 marks, I've divided this question into 2. So the first question is going to be why are alloys hard? That's going to be for 4 marks, and then why do metals conduct electricity? That is going to be for 2 marks. But I'll write my answer for you and then get back to you in a second. So these are all the questions I was talking about earlier that has a very, very strict mark scheme that doesn't really change from year to year. So whenever you see a question about metals, whenever you see a question about alloys, I want you to think layers, I want you to think sliding. Because in every single exam I've seen that has this question, this is what the mark scheme looks like. So this is a pure metal over here. It has layers, which can slide. So your first mark is for layers, your second mark is for sliding. And because it has layers that can slide, it is soft. This is our alloy. It has no layers, first mark, so there's no sliding, so it's hard. I didn't write this out in full. When you come to the exam, please just don't write layers and sliding, write proper sentences for me. And then why do metals conduct electricity? Because there is a sea of free or delocalized electrons that can move around. You could also have ions that can move around, and electricity is the movement of electrons. So seemingly a really simple and easy question, but unless you're picking up the keywords from the mark scheme, you're not going to be getting full marks for it. So our next question is about nanotechnology and why people should be concerned about it. I've also seen this as a, should people be concerned about nanotechnology? Yes, no, maybe. And any one of those answers is fine, just as long as you write something sensible down. So I'll write out my answer in full for you and then get back to you. So here's my answer. Quite short and sweet for 6 marks, but remember, this is science, not English. You do not need to write loads to get the marks. So very, very basically, nanotechnology is very small, and I mean very, very small. And things have different properties when they're small. Then a couple of examples. Nanotechnology has improved sun creams and medicines. There were lots of other examples you could have put here. So if you gave any examples, that's fine, and give yourself a mark. And then some people might be concerned about nanotechnology because it hasn't been around for very long, and most testing is done by companies. So when I say that people might be concerned because nanotechnology hasn't been around for very long, we don't know what the impact of nanotechnology use is going to be for 50 years' time. To explain that a bit more, we don't know how using your mobile phone every single day for 50 years, what that's going to do to you in the future, because mobile phones haven't been around for 50 years. But is it worth the risk to you? And, you know, everyone can make up their own mind about this. Is it worth the risk that something might happen in 50 years' time to get the advantage of using a mobile phone every day? I know for me it is, but some people feel very differently. And there's a lot of economics that comes into C2. Most testing is done by companies. Do we always trust adverts? Just because something says it's fantastic and better and improved, and the company's telling us this, do we believe them? So this is another one that, like nanotechnology, it feels slightly out of place in C2 because it's only a small part of it. But you need to know about thermosetting and thermosoftening polymers, the difference between them and what they look like. So it would be rare, it would be unusual if they asked you to draw pictures, but I'm asking you to do that here because I think the pictures here explain quite a lot of the chemistry really well. So I'll do that and get back to you in a second. So here are my pictures for thermosetting and thermosoftening polymers, and you'll notice that thermosoftening polymers are kind of like all jumbled up all over the place, where thermosetting polymers look like a brick. So give yourself a mark for each of those pictures. Now, the important thing and the important difference between thermosetting and thermosoftening polymers are these cross links here. This means that thermosetting polymers are in a fixed shape, and if you heat them, they're going to burn. Thermosoftening polymers can be reshaped. If you heat them up, they are going to melt and they can be reshaped and formed into something else. Okay, so there are two big maths topics in C2, reacting masses and empirical formulas. Chances are there's a very, very good chance you are going to get either one or the other question, so it's well worth revising this topic because they're generally worth about 4, 5, 6 marks, depending on what they're asking you to do. Now, I've been slightly mean here. I didn't give you the equation. In the exam, they probably will give you the equation so that you don't have to work that out for yourself. This is the equation we're looking at, and in the question it mentions zinc carbonate and zinc oxide. So even though I've written CO2 down here, we actually don't need to worry about the CO2 at all. So this is our equation, and then first thing we need to do is to work out the masses of each of these. So we're going to need a periodic table and a calculator for this. And I'll just work you through it slowly for those of you that need the revision. So the mass of zinc is 65, carbon is 12, sorry my pen's playing up a bit, oxygen is 16, and we have 3 of those, so altogether that equals 125. Now we need to do the same with zinc oxide. Zinc is 65 plus oxygen, which is 16, which equals 81. So we know in a perfect situation, if we had 125 grams of zinc carbonate, it would make 81 grams of zinc oxide. Now, there were lots of reasons why it might not be a perfect situation, and that's a different question, but I have made a video about percentage yields on that where you can look into that more. So in a perfect situation, 125 grams, tons, kilograms, whatever, it really doesn't matter about units here, would make 81 grams of zinc oxide. But in the question, we have 97.2 grams of zinc oxide, and I know I've made a bit of a mistake here, but for the purpose of the maths it really doesn't matter. So we need to work out how much zinc carbonate would turn into 97.2 grams of zinc oxide. So we need to think, what do we do to 97.2 to get to 81? And then we need to do exactly the same thing over here. So on this side we need to do 97.2 divided by 81. So 97.2 divided by 81 equals 1.2. So to get from 97.2 to 81 we divide by 1.2. Now we need to do the same but opposite on this side, so we need to times it by 1.2, which means this answer here would be 150 grams as our answer. Now, a way that you can self-check this is that, this in green, this number here is bigger than this number here, so we would expect this number here to be bigger than this number here. If you had done your maths the other way around, for example, if you had done 81 divided by 97.2, 81 divided by 97.2 equals 0.83, and then you times 125 by that. If you got an answer of 104, you've just got your sums the wrong way around, and this self-checking mechanism will get you back on track in the exam. So, things that I'll be awarding the marks for are working out the mass of zinc carbonate, working out the mass of zinc oxide, getting the ratios right, working out that you need to divide one side by the other side, and then getting the answer and popping some units on there. Okay, so I have to confess that I really like empirical formula questions. Don't really know why, I just really enjoy them. And I have a method that I really like my students to follow because it works when working out empirical formulas. So the first thing you need to do is write down the element. So we have iron, we have hydrogen, and we have oxygen. Let's make a nice little table for them there. The next thing we need to do is write down the number in the question. And for this question, it really doesn't matter whether we are talking percentages, whether we're talking grams, whether we're talking kilograms. It really doesn't matter. So for iron, the number in the question is 52.3. For hydrogen, it is 2.8, and for oxygen, it is 44.9. The next thing we need to write down is the atomic mass. So from our periodic table, we can see that iron is 56, hydrogen is 1, and oxygen is 16. Now what we need to do is to divide these two numbers here, and that's going to give us the number of moles that we have. So that's 52.3 divided by 56, which equals 0.93. 2.8 divided by 1 gives us 2.8. 44.9 divided by 16 equals 2.8. Then we need to divide by the smallest number, and in that case that is 9.3. So all of these numbers here need to be divided by 9.3. So 0.93 divided by 0.93 equals 1. This is our ratio here. 2.8 divided by 0.93 equals 3. And same maths here, that equals 3. So that tells us for every one iron we're going to have 3 oxygens and we're going to have 3 hydrogens. So our formula is going to be FeO3H3. You could also write it like this. The most important thing for empirical formula questions isn't really how you write your answer. It doesn't really matter what order the letters go in, just as long as you have them in the right ratio. So your marks. I'll give you the mark for the first part, a mark for the second part here, your third mark with the ratio, the moles for the ratio, and then I'll give you 2 marks for the answer because this is exceptionally hard. So in C2 it's unlikely that you would get a question that asks you about both of these in one. You might get part A and part B, or you might get a long question asking you just about one of the other ones. But to boost this up to 6 marks, I've put both of them in one question, and there are again a very few particular words that the examiners are looking for when they're going to be marking your work, so I'm going to pay particular attention to those. I'll just write my answer and get back to you in a second. So these are my 2 answers here, and you'll notice that there's a very similar pattern to them. This is because this is the sort of thing that the examiners are looking for when they're going to be looking to award you the marks. So increasing the temperature increases the rate of reaction. So I've given an example and I've told the examiners very clearly that I know what increasing the temperature is going to do to the rate of reaction. Particles have more energy, they move faster and have more successful collisions. This word successful collisions is really important, especially when you're talking about temperature. Because at a low temperature, at low energy, things could collide and not care. They could collide and bounce off each other and not react. So decreasing the pressure, deep pressure and concentration act exactly the same in this situation. So decreasing the pressure will decrease the rate of reaction. As there are less particles to reactives, there is less chance of a successful collision. I'm not going to give you the marks for collision unless you put the word successful in front of it. So in C2, again, like the maths question, there is going to be a question, 90% chance, there is going to be a question that is asking you about a method. And there are 2 methods they can ask you about. They can ask you about a rate of reaction, or they can ask you about making a crystal. So it's really worth learning all the different methods for making crystals and for measuring rates of reaction. But this is the one that I wanted us to do today. So describe a method for finding the rate of reaction between magnesium ribbon and hydrochloric acid. The first thing you need to know for this is that when you have your magnesium ribbon in the hydrochloric acid, it is going to bubble, and there are going to be bubbles of gas released, and that's what we're going to be looking for in this. So I'll write my answer nice out and full for you and then get back to you shortly. So here I've written out a very brief method for you. There are so many variations with this question that it's very hard for me to write down an actual answer because the question I gave you was very open. You could have written lots of things down. And again, this is the kind of thing that would have lots of things on the mark scheme. So even if you haven't written exactly the same as your friends, chances are you're still going to get both going to get really, really good grades. So I always like to use a measuring cylinder immersed in water to capture the gas released. You could use a gas syringe, or you could use a very sensitive balance to measure the loss in weight. Add a strip of magnesium to hydrochloric acid and place the bung on with a delivery tube as quickly as possible. Record start and end volumes, repeat 3 times and find a mean average. So you're going to get your first mark for telling me the method that you use. You're going to get your second mark for telling me that you're adding the hydrochloric acid to the, or you're adding the magnesium to the hydrochloric acid. Sounds like a silly thing to get a mark for, but you'd be surprised by the number of people that don't actually do this. Again, you'll be surprised by the number of people that don't actually tell me that you need to know the start and the end of volumes, that you need to repeat it and find a mean average. Now when they give this to you in an exam, if they give it to you, chances are it's going to be a lot more descriptive, and you're going to want to mention some control variables, and you're going to want to mention the independent and the dependent variables. These are going to be really, really important for getting your marks. If you're confused about this method or what variables are, I have made videos on those, so go and check those out. So I've seen this before. It has a long answer question. It looks quite intimidating and scary, but it really isn't. So what you need to know is that aluminium oxide is Al2O3, and that is made up of aluminium 3 plus ions and oxygen 2 minus ions. So at our positive electrode, and again, if this is a 6-mark question and you can divide it into 2 things, so here I'm dividing it into aluminium and oxygen, I want you to write 3 things, at least 3 things for each, and we're going to be saying that there are going to be 3 marks for talking about aluminium and 3 marks for talking about oxygen. Or you can have 3 marks for the positive electrode and 3 marks for the negative electrode. It's basically the same thing, just as long as you've divided your work up clearly and make sure that you've got enough to get all of those marks. So the positive electrode is going to attract oxygen. This is the reaction that's going to take place at the positive electrode. It is going to be turned into oxygen plus 2 electrons. Now writing it out like that makes it seem really obvious that oxygen is going to lose electrons. And hopefully you'll remember this. Oxidation is loss, reduction is gain of electrons. So oxygen is losing, so it's actually being oxidized. Now hopefully you remember that the positive electrode is made of carbon, so carbon plus oxygen is going to turn into carbon dioxide. And the other thing you need to know is that the positive electrode wears away. This is because the positive electrode reacts and turns into carbon dioxide. So the negative electrode is going to attract aluminium because opposites attract. This is the reaction that's going to take place. Is going to turn into aluminium, so it is going to gain 3 electrons. Reduction is gain, so it's being reduced, and then the aluminium is taken off at the bottom as a liquid. So lots of things going on there. Each individual thing is going to be a mark. but I only want you to give yourself 3 marks for talking about oxygen, 3 marks for talking about aluminium. There is a lot you can say about this question, but remember, this is chemistry, not English. You do not need to write a lot to get all the marks. This is an absolutely fantastic practical to do in class. It makes the prettiest blue crystals. I absolutely love doing it, and the examiners absolutely love asking questions about it. And again, they're really, really particular with the words that you should use. So I'm going to write out my answer for you and get back to you shortly. So here's my method. You need to heat the acid in a beaker. Again, this is a really important word. There's no point just putting the acid in a beaker, you have to add it. Heat it. So add the copper oxide little at a time until it stops dissolving. When it stops dissolving, you'll know the reaction has finished. This is really, really important when you see this word here, excess copper oxide. If it didn't say excess, it would say a specific amount, and then you should add that specific amount. Filter off the excess powder. So whenever there's a question saying how do you remove a solid from liquid, you filter it. People always get really, really confused by this, but the answer is simply filtering. Again, this is another bit people get confused by. How do you get crystals out of solution? You heat it or you leave it to evaporate, and then the crystals will appear. So you can give yourself a total of 4 marks for doing the method, and then 2 marks for some of the safety precautions. Goggles, tie hair back, wash hands once you're finished, and be careful with the glass. If this question comes up and you completely blank on what to do, this bit here, explain what sort of safety precautions should be taken, is going to get you 2 nice easy marks. So it's always worth writing something down. Well done for making it to the end. These are all super, super hard questions. But if you were a student in my class, this is how I would mark your work. So add up your marks out of 60, work out percentage, and work out what grade you've got. If you didn't get the grade you hoped for, don't feel disheartened. Remember, the actual exam is going to have some easy questions and some hard questions. These are all really, really hard questions. So if you manage to get some of these right, you're doing fantastically well. Let me know in the comments below how well you're doing so I can congratulate you. Thanks for watching. I really hope this is helpful. Subscribe so you don't miss any of my new videos. Share to help your friends get better grades. Any comments, corrections, questions or requests down below please.